Hi guys, Kieran from Team Chicken here again. We've got version 1.7.3 of DevKit coming out today. Just before I package it all up, I thought I'd show you a few of the new features. A bit of a walkthrough. So first thing, when you fire it up, if you notice here, there was a quick little status update, just tells you which plugins it's loading, pretty minor. But it does show that there's been quite a lot of work on the plugin system, which is a lot of the stuff I'll be demoing. So yes, the plugins, first of all, they come with, there's a few more of them, they come with documentation built in. So if you wanted to look up the display documentation, there's a little menu option there. That's just partly so that you can tell which version it's sort of built against. So if you've got a version of the dev kit, you can always check the documentation to see what spec it's running against. And yeah, that's in place for pretty much all of those, some of them more extensive than others. So something pretty cool that a few people have asked about, and I think is gonna perhaps be a bit of a game changer for UIs and so on. Multiple monitors. I don't know if Notch has anything in mind for it, but obviously we do. So the plugin for the LEM 1802 has a little configure settings option here. Very straightforward. All you can pick is the number of devices, devices being number of monitors obviously. So if we start with you can have obviously 0 as a minimum and 10 as a maximum. There's in theory no maximum, but it kind of doesn't fit on the screen. So we start with 1. This is a little test program I'm using, just something where I've got a bit of sort of standard hardware detection, really basic interrupt handler, and then just a sort of test program, so it will call through to init standard devices, then do some tests. So at the moment it's just outputting some random stuff to the screen, which is relevant for a bit later on. So if I fire that up, obviously you've just got one monitor. Looks pretty good, about the same as before. Yeah, if I then fire up the plugin, attach another one, sort of doesn't initialize till you restart it, but you've got 2 monitors. Now it works hopefully in the way you'd expect, whereby here we are, we're checking to see down here if it matches the monitor's sort of ID. If it does, then it will write to a particular memory location which stores the hardware ID, and obviously if you've got 2 of them, then there's 2 of them stored, and we can refer to GPU device, GPU2 device. That's just what I've done. In fact, I think I mapped them to that address and that address, and it's really is quite straightforward. You just write to either address. I think here we're writing to that range, and here it's adding another 1000. This pattern is a bit of an odd one. In fact, it's to do with another feature, which I might as well get onto now. You can add different file types into your solutions, into your projects, which also leads on to another part of the new functionality. If you can click add existing file on the context menu of a project, and you can basically pick an existing file, chuck it in there, rather than having to create one each time. It's kind of a bit of an obvious one, but yeah, very useful. So as a part of, there's been a lot of work going on to try and get different file types and different languages supported in DevKit, and as a result of that, there are a couple of sample plugins, which are the binary resource support and example basic. So binary resource support basically adds support for .bin or .dat files, and if I double click that, it has a very simple editor UI here. Again, this is actually demonstrated in the source code for the plugin, which you can download from the GitHub repository. Hopefully by the time you see this, right. So very simply, this file, when built, will be put into the solution and available through other code, kind of showing interoperability by a label. So when this test.bin gets compiled, the words are just inserted into the output stream, and it's given this bin file identifier so that you can refer to it in your code. So it's let me see here. Let's have a look at the contents. Very straightforward. I think this is, yeah, quick brown fox jumps over the lazy dog. So that was just obviously a test, and what the current test program here is just dumping that onto the screen. Obviously every other byte is a color word, so it doesn't quite make sense there, but demonstrates the feature. Okay, so we've done multi-screen, we've got some new files, bin.dat, yeah, you can add existing file, and you've got here all the plugins that have file types associated are listed, so you could add a .bin or .dat. I don't think I have any there, but yeah, you can pick whatever you like. The other main feature, and a lot of work has gone into it really, is the disk drive feature. We've gone ahead and implemented the HIT HMD 2043. I think it's a fairly good, obviously, description of how a floppy should work. It's really great, to be honest. Notch has indicated at one point that he wasn't interested in people writing their own hardware specs, but then said actually he's going to go ahead and implement this. Obviously, we're not counting on it 100%. If there are changes, or it's going to be a different kind of drive, we'll strive to get that sorted as quick as possible. But in the meantime, this is a lot of fun to play with. So there's, in much the same way as the screen, you've got a configuration screen. So if we pick configure disks, you've got this nice UI here, and effectively on the left you've got your list of your drives, which you can modify with this drop down, and on the right you've got a sort of disk library. And what I wanted to try and get at was, especially with these little icons, was to recreate some kind of nearly physical interface. So literally you can drag and drop a disk into a drive, it disappears from your library. Imagine that's like a shelf or a stack or a disk box or something. You can eject it back in there, you can pop another one in, it'll automatically eject it, and so on. If obviously this disk library is just a plain list at the moment, there might be some categorization later, but for now you can create a new disk. .10c disk is just something made up. It's in the BIEF format, which I'll show you in a sec. So if we just chuck something on the desktop, demo disk, it just creates a blank file, well, not a blank file, a blank disk that you could then use and swap around and whatever. This library is just stored in XML on disk. You can browse and add ones to the library if you wanted to get it into the library on another machine, for example. So we'll take a quick look at that demo disk. Notepad's very handy. This is the format. It's kind of nice. It's zlib compressed, just by default. I think that's what the library does, and then we've added some extra bits and pieces here to store the flags, and the idea is this can store any kind of media that the drive specification as it stands at the moment can work with. So it doesn't look too interesting, but you can kind of see here that there's lots of options which might be changeable for different kinds of physical parameters for a disk. Okay. This is, I don't think it's new in this release, but the previous one, you can have defines here, and it's quite easy to put together a bit of an API. And I think what we're doing here is just testing a few API calls. So if media is present, you can check the media quality, you can set an interrupt message, write some sectors and read some sectors. So what this is actually doing here is that's just obviously a test. Another test, this is setting up an interrupt, again not strictly speaking required, but useful again for testing. And all we're doing here is writing some sectors, and we're writing 3 sectors starting at the address of the video memory for the second screen. Setting some nonsense here to say non-blocking and use an interrupt, or rather non-blocking and give us an interrupt when a disk is ejected or inserted, and that works as well. And then we're reading back onto the other screen, so it's kind of a really slow memory copy from the second to the first. So now we've got 2 screens, it should be possible to see that. Nope, not just yet. We'll see what's going on. We haven't loaded any disks, of course. So that would have been returning an error code. Configure disks. Now at the moment this code here only deals with one disk device, and it's pretty stupid. It whichever drive is found last is used. So drive B here, or if we had one then drive A, is the one that's picked up. So of course you need to have a disk in the drive, otherwise this test won't work. Let's try that. So it's actually pretty quick with the delay of the screen as well. It's too quick to see. I'll chuck this frequency down, see if that makes a difference. It's kind of nice to see the 2 monitors there, sort of live and interactive. The disk works in a fairly accurate way with blocking or non-blocking and the appropriate delays for reading and writing sectors, so it should be fairly good. Yep, so that's a successful test. It was obviously reading and then writing, and that all works nicely. Okay, let's see now. There's some new output types. By default, previously it was outputting a .bin file for the whole solution, and had a few requests, so as well as the .bin there, which just obviously doesn't translate very well. Mind you, you can see the binary there. We've got a hex file, which I haven't actually tried this, especially the disk test, but on, say, Xcode. Or I should say this one. Let's give it a quick go. Oh, that's nice. So obviously it displays the left-hand screen there. It's detected one device, but I guess the drive calls aren't working or may not be working. So that's good. Also, this is sort of preempting some desire to obviously do something useful with the disks. It just dumps the compiled output in disk format. So there's a few things that we've got next on the radar to tackle, like relocatable code. At the moment, code assumes that it's running from starting location 0, and it's definitely one of the very next things we're looking at is to have code detect where it's starting and write some fix-ups and get some jumps working in a relocatable way, which helps with things like loading programs from disk and so on. Yep, it outputs to a disk file, so if you wanted you could then load that disk back in and do something with it, load a program, try something else, I'm not sure. So hopefully that gives some options for getting going with disks. We've got a load of work done in the plugin system for new languages, so just a quick word on that. It's possible to write a plugin which implements the iPlugin interface. This is sort of a .NET developer thing. Hopefully everyone's comfortable working with sort of interfaces and just implementing stuff as a decent means of representing a plugin system. You implement an interface, you add some you register your file type provider with the system, and then it hooks into all the appropriate places, like the add file. You can create a new kind of file. I'll demonstrate this actually in the add existing file, and obviously when it builds, it's all based on extensions at the moment. So if we and this is a sample plugin called Example Basic. It doesn't compile down to any instructions. What it does is demonstrate a few of the new plugin API features that this one doesn't. The binary file. So the binary file one gives you a custom UI. Which is defined in the plugin for representing a file in the workspace. It shows you how to insert a label identifier and as such cross-integrate. I don't know. You can get two different files or languages working together. This isn't a language, obviously. It's just a dumps a load of words to the output, but it can refer to identifiers and other scopes, and it can also define them itself. So that doesn't help much if someone was keen on, for example, getting a C language compiler hooked up. So to demonstrate some other bits and pieces, there's this example basic. As I say, it doesn't compile, but it does show, for example, that you can use the as well as a custom UI there, you can use the existing built-in DevKit text editor, which is nice and fairly advanced. I should have put this zoom up to begin with. And custom highlighting rules. So obviously we're highlighting numbers, basic keywords. Basic keywords, and basically from that you've got your integration with the UI. You've got your further integration with the UI to get the file edited, and also if you try and build, it'll run the build process. Great. Now there's a bit of a warning in here. Basic compilation warning. Example Basic does not currently compile code. But the code behind the plugin is there for a reason, obviously, to demonstrate a level of integration and a subset of the features. This one compiles code but doesn't have much of a UI. This one doesn't compile code but has a bit more of a UI. So hopefully that's a good ground to get going. If people do want to add languages, add language support or file type support, or even, of course, you could get some tools in here. You could add a .png file and have it a nice UI, for example, for defining how it should appear and all that kind of thing. Oh, and I should add, we're working on a pixel editor at the moment for fonts, sprites, etc., and that I imagine would be a similar deal to this. If anyone does have any questions, problems, etc., getting the plugin UI, the plugin API rather, up and running or working, obviously they should get in touch. Best place for that at the moment might be email, Twitter. If it's a bug or a feature request, then the GitHub issues repository is good. Other than that, in fact, I'm going to post a link to this Stack Overflow style site that I've set up just to see what the response is, and perhaps that might be a good place to ask those questions as well, or perhaps on a forum. We'll sort something out. Okay, right, finally I wanted to move on to something and sort of pose a question at the same time. So we've got all kinds of things going on now. We've got disks, we've got kernels, loaders, and things are getting a whole lot nicer. But we need a way of preparing a disk. People have come up with file systems, whether simple or not so simple, for these disks, but how tools will generate disk images or file systems or interact with those file systems isn't really defined. No one's that I know of, and tell me if they have, come up with an idea for how to put them together. So really I was looking for to see what everyone thought would be, perhaps there's a standard way, for example, but see what everyone thought would be a good way of putting disks together or combining build output in an interesting way. So marvelous tool for mocking up stuff, of course, is Excel. Let's have a quick look. So what I was thinking was, if you've got a project like this workbench, pretend it's a game or something. You might have a bit of a bootloader, or there might be a standard operating system that knows how to load disks, load the appropriate part of the disk or file on the disk into memory, and obviously jump to the code. That's kind of how things work. But if you've got your project here, at the moment you'd need to have your operating system in there and somehow prepare a disk image. At the moment that would be a separate solution with just the code in the right place. Whether it's relocatable or not is difficult to say. It's all a bit complicated, so I figured we could have a bit of a change. If you imagine the structure at the moment is solution and projects, we'll instead have solution and then say build outputs. Build outputs, perhaps. So under build outputs, we might say that we want to produce something that's going to go into emulator memory and something that's going to go into disk. And imagine that's sort of a tree structure like that. And then you've got your projects. In fact, would the projects be? They'd probably just be at this level. Let's say my game loader environment. Let's say that's some test, some way of testing the game. I don't know, something like that. So these are projects. These are build outputs. Something decent. So at the moment, as it would be, all of the projects are compiled in order. The first file of the first project is the entry point, compiled down to offset 0. Not great. Everything's dumped on a disk. Everything's dumped in memory at the moment. It's not great. So what I was thinking was, you can add build outputs, and a build output is like a definition for something that's going to be produced. And emulator RAM. Say that's one of your build outputs, and imagine this is a dialog. Perhaps it could be nice like the disk one, drag and drop and so on. So you're defining what's going to go into emulator RAM, and you might also define separately what's going to go onto disk. Perhaps another dialog. So emulator RAM, you could pick, let's see, pick your projects. Now RAM might need to be divided up. You might want something to load into offset 0 and then something to be loaded somewhere else in RAM just as a test. So you'd have a output group, something like that, and from there you'd pick your projects. So you'd say you want the loader environment, output group main, and you'd pick, for example, that starts at offset 0, and you'd pick your project, loader environment, and then you'd have another output group, let's say target. Good example. There's not much in high memory at the moment. My game. So for emulator RAM, as in when you click the run button, the build and run button, it will build each of these output groups, and they will be loaded into emulator RAM in some way, and the output group defines where it's loaded and also some details about the build. For example, loader environment here is built in isolation on its own and then dumped at offset 0. My game is built in isolation and then it's dumped at offset B000. You could have some options here for the output group to say is relocatable. So if you had a relocatable option, that would be built to be relocatable. So it could be loaded anywhere in memory. For example, it's in B00 there, but it might be loaded somewhere else. I don't know what other options you might want there, but for example, if you just wanted it to run, that code, you could instead have a single output group. Say here, you put my game here. It's not relocatable, it doesn't need to be. Might save some code space, I don't know. And it would just run. So what you're doing there is defining the state of the emulator when it fires up, what goes where, and sort of the output groups are a nice way of doing that. So for disk, however, you might want to output files. You might want to output a boot sector. You could do something like this. Boot sector. Well, that would just be a definition like that. Output group. Boot sector. And then you'd put something like, let's see, well, of course we don't know how that's loaded into memory. Let's say the same thing. And then here you could either define that output group data sector 1, something like that, contains my game. Let's see, is relocatable. So in this way, when you click build, the emulator will be loaded in this way, and the disk, or the disk, of course that's not defined either, would be produced in this way. So you'd have a boot sector that was with this, and a data at sector 1 with this. And then depending on file systems, of course, that could be completely different. It could be that we want to say file my game dot, I don't know, something like that. So it could be that the disk is built in this way. It has this boot sector, but there's a file system defined. File system, my simple file system, and then a file's produced. So I kind of thought this was a nice way of putting together outputs. Either you're building a disk and you get to specify how it all works, or you're building something in memory just to try it out, or a combination of the two. You could have the emulator RAM loads an operating system, and a disk is built here, has a boot sector or not, and has some files and data and so on. These needn't be projects, but I imagine in most cases they would be, but they could equally be binary files. You could just pick files, perhaps there could be a project of just files which are built and output there. Anyway, if anyone has any other ideas for how to put this stuff together, there could be a file explorer or some command line tools, and you could build up a make file, something like that. Let me know. Very interested in hearing. Either comment on this video. In fact, comment on this video. That's a good idea. Let me know what you think. Okay, so that's kind of a rundown of new features. A bit of background about the plugin system. We've obviously got nice disk UI, we've got the new screen, and we're looking to continue to build nice features into DevKit. As I say, there's lots planned at the moment. There's going to be more planned. Very welcoming of feature suggestions and bug reports. Yeah, let me know what you think about the disk builder idea, or rather the build output idea. So DevKit 1.7.3 should be available by the time you see this video on the website. You should get a little update message if you run the app as well. And I'll see you soon. Cheers, bye.